guys, and welcome back to my channel. Today in this video, we're going to be exploring the world of quantum computing by interviewing Dr. Paweł Gora. In this exciting video, we're going to be explaining and talking all about qubits, quantum computing, and how quantum computing can actually be a threat to cybersecurity in the future. So, stay tuned. Hello, Dr. Gora. It's a pleasure to meet you today, and well, I'm really excited.
Hello, it's nice to meet you, and thanks for the invitation. It's my pleasure to have
Thank
this
you.
conversation.
Okay. Well, first question to start this off is gonna be, what is quantum computing for our viewers which don't know?
So quantum computing is a new or a bit different paradigm of computing, different than the standard classical computing. So as some of you probably know, in classical computers we store information using bits, and we use classical gates to process data, to process information. But in case of quantum computers, we have qubits and we have quantum gates. So the processing of information is a bit different. And one of the differences is that in case of quantum computers, we directly take advantage of the laws of quantum mechanics, like super single qubit. We can store or carry information about the values 0 and 1 at the same time. So when you have a single bit in a classical computer, the state of a single bit could be only 0 or 1 in a given moment, then you can change the state. But in case of quantum computers, a state of a qubit could be in a superposition of state 0 and 1. So you can carry some information about 0 and 1 at the same time, and the computations are stochastic, they are not deterministic. So when you repeat the computations multiple times, you can get different answers. And you can modify, using a quantum gate, you can modify the probabilities of getting different results of your computations, basically.
So, to summarize, it's a computer that uses qubits to find multiple answers.
Process information.
Yeah, sure, but in what makes it special to other things and other computers?
So when we have classical computers, and let's assume that we have n bits and classical bits. So on these n bits, we can store a single n-bit number and process a single n-bit number at a given time. When we have a quantum computer, we can potentially, and we have n qubits, we can process all possible 2 to the power of n-bit numbers at the same time.
So you can process multiple. Okay.
Yeah, it can give us a better computational power, so we can solve some computational problems faster or better to be able to find better answers. And besides the superposition, we can also take advantage of another phenomenon of quantum mechanics that is called the entanglement. So we can entangle 2 qubits so that one qubit could be a controller for another qubit. And it can also give us an advantage in terms of computing speed, for example, right? So in general, quantum computers will be able, hopefully, because it's still not sure in some cases, and we still do not have large and powerful quantum computers. But theoretically, quantum computers should be able to solve some computational problems faster and better than classical computers.
Sure, because it
Not
can.
all problems, but there are some classes of problems in which we should get an advantage.
So you're saying that quantum computers, what they're different from classical computers, is that quantum computers, they can calculate and do multiple functions at the same time, unlike classical computers, which have to do one by one.
Yes.
Okay. Well, what even inspired you to do this?
This is a long story because I started working in academia more than 10 years ago, and initially I was interested in optimizing transportation in general. At some point, I learned that quantum computers can give an advantage in this case as well, so they could help us solve some optimization problems in transportation faster and better than classical computers. So I started learning more about it, and in general, I was almost always interested in physics. So I also attended some lectures in physics, and I was interested in quantum mechanics as well. So that was very interesting from a scientific point of view, but also from the point of view of applications and the potential impact on the world. I realized that this is something that is worth studying, definitely, as it has a potential to give an advantage and let us solve some difficult problems faster, better. Perhaps thanks to quantum computers, we'll be able to design new chemical substances or to simulate chemical reactions, to design better drugs, better materials, and so on. So it may have a tremendous impact on the world and society. So this was one of the motivations that led me to studying quantum computing more.
Okay, great. And so, how did you first get into that?
In case of quantum computing, this was a very interesting story because, as I told you many years ago, I was working on optimizing transportation, and I was invited for an interview in a radio, so similar to this interview. And one of the participants who listened to my interview learned about my project, and he invited me to start collaborating with him on optimizing logistics using quantum computing. So that was very exciting.
Okay, sure.
Yes.
Yeah.
So it's possible that after this interview, maybe someone also got interested in quantum computing, and later sent me some emails with proposals similar to the one that I received a few years ago.
All right. And so, what makes physical architecture of quantum computers so different from normal computers and from the traditional sense?
We require totally different hardware for this, right? So in case of classical computers, the hardware is more or less already a standard in the industry, we can say, right? So the first classical computers were built more than 8 years ago already. So as for now, the architecture is quite standard. So we try to build better and better classical computers and scale them with better density of transistors following the Gordon-Moore's law and so on. But in case of quantum computers, we need a totally different hardware. And it's good to know that there are different approaches to build quantum computers. So depending on the approach, the architecture of quantum computers could be different. So there are approaches based on superconducting, based on ion trap, based on photonics, based on neural atoms, and so on. Usually this, let's say, the hardware is quite sophisticated. So very often we need very low temperatures. We need to keep the qubits in very low temperatures. They should be isolated from the environment. So there are still some, let's say, engineering challenges with building a quantum computer. So this is also one of the reasons why the contemporary quantum computers are still relatively small and noisy. But indeed, there is a lot of electronics. There are different hardware components required to keep the low temperature, for example, to process the qubits. So there are also different approaches to design the quantum gates, modifying the probabilities of getting different results after the measurement of the qubits. So it's totally different and very sophisticated, very advanced hardware.
Sure. And so apparently I heard that you need to work in an extremely cold environment to actually build these quantum computers.
This is true because one of the reasons is that we need to isolate the qubits from the environment, because when there is an interaction of the qubits with the environment, we can totally lose our quantum information that we store on the qubits. So in order to prevent it, we need to operate in an environment that is close to vacuum, and we need very low temperatures as a consequence. This is also one of the important components of this hardware, quantum hardware now, to ensure that we keep low temperatures. Of course, there are also approaches to build quantum computers that could operate in higher temperatures as well, but it's not the nearest future, definitely. Maybe at some point in the future we'll have it. As for now, we usually, in most of the approaches, we need very low temperatures indeed. And we need to keep these qubits in the so-called state of quantum coherence and ensure that they are isolated from the environment.
So I have another question. How will quantum, because I know that you also have a field in cybersecurity, I believe. How will quantum computing affect cybersecurity?
Yeah, so this is a very interesting topic because, as some of you probably know, that many of the contemporary encryption methods are based on the assumption that some computational problems are difficult. So, for example, the factorization problem is an example, right? So when we have a very large number and we want to factorize it. So this problem is believed to be difficult for classical computers. And based on this assumption, we designed some very good but also very popular encryption methods, so cryptography methods. And now we know that quantum computers will be able to solve this kind of problems very fast. So we know, we already know the algorithm that is now the Shor's algorithm that is able to factorize very large numbers relatively fast.
Sure.
So in a time that is, let's say, proportional to a polynomial function of the size of the number of bits of the number that we want to factorize. And it means that it's very likely that quantum computers will be able to break many of the contemporary quantum algorithms in the future, which is one of the reasons why researchers have started working on the so-called post-quantum cryptography algorithms. So the classical algorithms that could be resistant to attacks using quantum computers. So this is one side. But on the other hand, we also have something like quantum cryptography. And so quantum computers can be used to break classical cryptography algorithms, but at the same time, quantum technology, maybe not necessarily quantum computing, but rather quantum technology, could be used to enhance our security. So, for example, we can build something like quantum random number generators that could really sample numbers for us really randomly, with the randomness that we can observe in our
Of course, of course.
when we have classical computers, we usually use some kind of pseudo number generators. And if the pseudo number generators are not perfect, then they could be also hacked.
Okay.
Right? So this is one of the one of the ways how quantum computers can help us.
Yes.
Also, there is something that is called quantum key distribution. And in quantum key distribution, we can also communicate private keys, private or public keys that could be used for encryption using other methods, and we can distribute them safely, so that if we, for example, we cannot prevent the situation that someone reads our key, but if the information is read, then we'll be notified and we could change the key. For example, we can generate it once again.
Okay,
This
so
can increase our security as well.
So since quantum computers are a new type of computer from the traditional sense, will we need new algorithms and programming languages just to compute it?
Yes, definitely. We need different algorithms. So quantum computers will not, let's say, allow us to run our standard classical algorithms faster. So it's not something like graphical processing units when we can just parallelize some existing algorithms. Instead, we need different algorithms as well. And for example, the Shor's algorithm for factorization is a new algorithm. It's a quantum algorithm. And it is indeed based on taking advantage of this superposition and entanglement phenomena that I described at the beginning of this conversation. Also, there are some other very popular quantum algorithms like variation quantum eigensolvers or Grover search algorithm or Deutsch algorithm and so on, Simon's algorithm, Bernstein-Vazirani's algorithm.
Okay.
So there are different algorithms. There are different algorithms that can be used for different kinds of problems.
Sure. And
these algorithms are different. So they can be simulated. Potentially they could be simulated on classical computers, but the simulation will not be as efficient as just run of this algorithm, the quantum.
All right. So why are ethics in AI so important right now?
So in general, the ethics is important in our life. And it is important both in quantum computing and in AI as well, because you know. So for example, when we go to AI, many things depend on the data that we use to train our machine learning models or AI agents, AI algorithms, and then our AI algorithms could be biased. So, for example, they can give me some recommendations or make decisions that may favor me or you, but not other people, which is not good. So that's why this is important. Another thing is that many machine learning algorithms are trained on some publicly available data, but the thing that some data sets are publicly available doesn't mean that we can
Sure.
do whatever we want with them.
Okay.
So, for example,
So-
there might be some personal data, so they can do harm to people. right?
Yeah,
So,
of course. So
yeah.
yeah. So now that we talk about AI and that stuff, what do you think kids should think about as well we grow up with AI and quantum computing?
Okay, I think that one important thing is to know is that the future in, let's say, 20, 10, 15, 20 years from now can be totally different than the present state. So the technology will be different, the access to knowledge will be different. So some problems that exist nowadays probably will be already solved by, let's say, 2040, for
Yeah.
example. We should learn to be flexible. We should learn to be flexible to adapt to the changing conditions, to the changing world, to new technologies. We should be able to learn quickly, to adapt new technologies and take advantage of them, of course. And yeah, so this is one thing that we should keep in mind. But as you also said in the previous question, that ethics is very important. We should always try to keep it in mind that even though we have better and better technologies, and we can do better and better things with them, solve more and more difficult problems, it's always important to keep these principles of ethics
Okay.
in all our activities.
Sure.
Mhm.
So is AI in defense more risky than helpful? Because, like, also,
Yeah.
can machines really make decisions in situations where human judgment is needed? And like we saw in the movie Terminator, I mean, we can see what can happen.
So it's a difficult question, right? So in the ideal world, when there are no wars, we would not need AI in defense, right? But when we still have wars, there are some threats in
Yeah.
different countries, in different geographical areas. Then I believe that all the things that may prevent the war are important. And so, for example, we have nuclear weapons as well, right?
Yeah, of
So
course.
they can do a lot of harm, but at the same time, some people claim that thanks to the fact that we have the nuclear bombs, the nuclear weapons, prevents many very large-scale wars
Yeah.
in the current world, right? Because some countries, some people, some leaders are just afraid that other countries will use a nuclear weapon. It can be the same with AI, right? So
Yeah.
they can serve as a threat to some nasty people and can maybe prevent them from taking some very bad decisions. But on the other hand, there's always a risk that some bad people can start using it not for defense but to attack other countries.
Okay. And so, if we don't build AI with right values now, is it too late later? Another way to say this is, can you fix the ethics of AI once it's already big and powerful?
It's hard to say, but indeed I think that it can be more difficult to fix it. So usually, when you make mistakes and you design something incorrectly, starting from the basics or starting from the fundamentals, then sometimes it's very difficult to fix it and to improve it easily. And I think that with AI it can be the same. So, for example, one of the impacts and one of the consequences of the development of AI is that currently on the internet we have more and more artificially generated data. And in general, some people say that the quality of data available on the internet decreased in the recent years.
Of course.
And this is something that is very difficult to be fixed, right? Because, the amount of the AI generated data is so large already that so first of all, new AI models are also trained on the AI generated data from other models. And on the other hand, it can be really difficult to identify all AI generated images or data sets on the internet.
Sure.
So I agree that if we do not think and design the development of AI starting from the correct principles nowadays, then it can be difficult to change it later.
Sure. And our second last question is going to be, what excites you the most in about the future of AI and computing, and like where it's headed? So what are you most excited about it? And even with all the risks in there, is there something that gives you real hope in that?
I try to stay positive about the future development of AI and computing, including quantum computing. So even though there are some risks, I still believe in humanity in general, and I still believe that people who are, let's say, the brightest minds on this planet, the smartest people who are able to develop powerful AI agents, they're also smart enough, let's say, to coordinate this development of an AI in a responsible and ethical way, right?
Yeah.
This is my hope, at least, right?
Of course.
Thanks to that, I hope and believe that in the future, AI and computing may help us in curing most of the serious,
Yeah, of course.
like the cancer, for example, right? Or find some vaccines for new viruses, like COVID-19, for example, right? So I hope that the impact of AI and quantum computing, will be rather positive in the future, at least in the long term. But it's really hard to say. So on the other hand, we should also keep in mind that the more powerful AI we have, the more automation we'll have. So for some people, it can be also difficult to find a good job for them.
Yeah.
I believe that human interactions will be more and more important, because AI could substitute humans in
Every other way.
many, let's say, yes, in many ways, indeed. But for sure, the human interactions will remain. Hopefully, will not live in isolation, of course.
Yeah.
The world can be different. I can already see that now the world is totally different than it was, for example, in 2019, before ChatGPT, before the new large language models, before the pandemic, before the war in Ukraine, and so on. So the world is still changing. It has already changed a lot in the recent years and still changing.
Yeah.
But I try to stay positive.
Of course. And finally, last question before we end is, what is your message to the viewers?
The main message is remember to learn all the time. So it's important the lifelong learning is important, right? So even if you go to school, invest later in your further education after the school or beside the school. Try to develop your skills as much as you can. Identify what really makes you happy. What are your hobbies? Depending on what are your hobbies, your interests, and develop your interests in a given area, in the direction that you prefer, of course.
Of course.
And it's important to grow,
Okay.
to understand the world better. And then when you understand the world better, you will, independently on how the technology evolves in the future, you should be able to adapt easily.
Of course.
So you will always have an advantage. So try to keep the scientific curiosity, ask questions, try to understand some things about the world that you don't understand nowadays. Be active. So don't be afraid of asking questions. And things from people who are more experienced.
Well, amazing. Okay. Well, thank you so much for today. It was really a pleasure.
Thank you.
And bye.
Thank you. Bye bye.